Hey everybody, we are continuing the calculus video, and in the previous one we had just figured out this one and got it. So now we're on this one. When it says absolute value y equal x, that's not the same thing like you're used to, where it's y equal absolute value of x, which would be a v. So it's actually the opposite, so it's really like going to the right. So that's D. One way to type this is if you go to your calculator and add graph, and you see where it says F1x, I'm just going to press the delete button and change it to a relation. And see, press the absolute value symbol and then y, and then move over and then equal x, and so there it is. So that's using your relation part of your graph. Now the advantage of the relation is it does show you the graph of it. The disadvantage is the table doesn't work. Control T won't work. So even if you go to menu table, you see it's not available. It's skipped over it. The reason is because for one x value there's two y values, and so the table can't exist because it's not a function. But at any rate, that is the graph, and then that kind of goes into why is it not a function? For each positive value of x, there is more than one y value. In fact, there are two values of y. So that's C. Okay. So like if you go to 5, then it'd be up and down. Okay, so for B, which of the following is y squared equal x squared? Okay, so let's go back to this, delete, and say y squared equal x squared, and it's an x. So the relation is the easiest way to work this, and it's going to say there's two values. So for each non-zero value of x, there's two values of y. I suppose on this there's a different way to do it besides relation. We could take the square root of both sides, and so when you do that, it's like the square root of y squared equals square root of x squared. So you'd have plus and minus y equal plus and minus x. And then this one is y equal x, and this one is y equal negative x. And so it covers both situations. You don't really have to do that. You can just remember, change it to relation. And notice I didn't even bother solving for y. Now, like on the algebra EOC, you have to be in press to test mode, so relation mode is not allowed. But for this, you can. Okay, the next one, number 10, graph the function. So, let's see. When you are right of 1, it's going to be 3x. So you might want to make a small table. Okay, so let's just use 2 points because these are linear. So let's do 0 and 1 for those. So this would be 4 minus 0 is 4, 4 minus 1 is 3. So that's going to be the left side. And on this one, something bigger than 1, 2, And so 3 times 2 is 6, and 3 times 3 is 9. So when I graph that, I've got 0, 4, 1, 3, 2, 6, so twice as tall, and 3, 9, which is even higher. So it's like a big check mark, and so that's A. So that's if you do it by hand. If you do it the other way, this time we can't use the relation part. We'd have to press the button to the right of the 9, go into the piecewise part that's 2 by 2, because that means 2 conditions with 2 expressions. So the expression is 4 minus x, the other expression is 3x. So that's your normal equation part, but then it's like the condition means where is that? So you have x less than or equal to 1. So we put x, then you notice this little equal sign above it has some more inequalities, and so if we do control equal, has a pop-up box, and we want less than or equal to, and then we put 1. Then for this part we want x, and again control equal, and we want greater than 1. So now this looks like that, and then it goes. So it's kind of like a V that's off to the right. Now that's actually a little tricky. I mean, I guess that's the only one. But if you notice their window, this is just going from 0 to 8. And so if I double click here and put 0, then it's going to look closer to what we have, which is that. Alright, so that's how you graph the piecewise on the calculator. That's what we're going to do on this one as well. So I'm going to go to a new document, add graph. You know, before anything, I'm going to notice all these are pretty big windows. So I'm going to do -20. Click in there, -20 to 20. And then I need -190. Oops. To +190. So I'm clicking in there and I'm typing over it. Now, if you didn't like that, then tough. No, I'm kidding. Then go to menu, go to window, which is 4, and then go to settings, and that's where you'd have to make X-min and X-max 20, well, -20 and 20. Keep your scale like it was as auto, and then put Y-min as -190 and Y-max is 190. So in other words, X-min -20, X-max 20, X-scale auto, which means it could count by 2s, 5s, 10s, whatever. And then Y-min -190, Y-max 190, and Y-scale auto, which I would guess is going to count by 10s, but it's just whatever. Okay, so now we have the windows set. So now we go back to what we just did. We press tab to get F1 available, and then we go menu. Well, actually we go to the right of the 9, which is your piecewise, and you go 180 minus x squared, and you go x squared plus 2x. Then you do your conditions, x control equal less than or equal to 9, and x control equal greater than 9. And then there it is. So it looks like it's going to be A. So when you think of it, it's an upside down parabola, and then it's starting to go up. And here's another way to just rule out choices. This tells you everything's happening at 9. Well, it did change at 9. This one is just weird because it's got something up there and something here, but that's at 0. Like around there, it's not at 9. This one's like converging. That's weird, and this is overlapping. So it's that one. Okay, so number 12. Now this is one that you have to find the equations, and so it's a little tricky. It's related to piecewise, but again, let's take parts. It's going from this to this, and it's rising 6 and running 6. So that means my slope is 1. And my y-intercept is 0. So that means I have y equal x. And that's happening from 0 to 6. On the other part, we're falling 6 and running 6 more, so that's a slope of -1. And if you extend this straight, this would be 12. So that means your b would be 12. And so that would look like y equal -x plus 12. And that's when it's going from 6 to 12. Now, this actually looks very, very goofy on paper. What you're going to want is, well, you have your conditions and so forth. It overlapped here, so it's like a printing mistake. So it looks like this, y equal x, which is what I had from 0 to 6, and y equal -x plus 12 from 6 to 12. So it's basically what I had. Now notice they put less than or equal to for both parts here, and then if you have it for here, you can't have it down here. So then the third one had the equal also. Then on this one, let's see, that one is horizontal lines, so that's just going to be y equals 0 when you're going from -4 to -2. And that's going to be y equal -2. That's when you're going from -2 to 0. Now, because you see the top one had a solid, that means it has to be less than or equal to for that part. And down here it's an open circle, so that has to be an open circle here. So that's basically what we get. So, oh, did we get the 0? Yeah. Y equals 0, and that happens from -4 to -2. And then it was -2 going from -2 to 0. And it had to be the one with the less than, not less than or equal to. Okay, so that's that one. I can see why on paper that one's confusing. And it's probably not that easy either on the computer, but I have seen harder problems like this. This one's harder than that one. So on this one, Number 13, you start with what is the y-intercept of this, and it's 4. And what is the slope? I'm going to put b equal 4. And so this one you're going down 1, 2, 3, 4 units and right 1, 2, 3, 4 units. So 4 over 4 is 1, so your slope is just 1. So that's y equal x plus 4. Except it's down, so it's minus. So your slope was really -1. I'm sorry about that. So that would have been -4 over 4, which is -1. Okay, so we know this slope has to be negative. Now what you notice is it's a little open circle there, and so you can rule out the A and the B choices because you have the 0 with the open circle. Now on the right side, this one has to be with the closed in or filled in, and so that's how I know it's going to be C, because of this part right there. And so then I can fill in, so I've got y equals, so I put -x plus 4, and then this is 0 to 4. Now the other part, we're going from 4 to 9, unless we're counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, no. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is going from 4 to 9. Now the part we haven't gotten yet is the equation. Now if you don't like just extending it, that's okay, because sometimes it's not going to be an exact number. Like on this one, it's not. So this is really making you do your math skills. So what do we do when we know 2 points? We've got 4, 2, and we've got 9, 0. How do we figure out that slope? Well, what we do is we do y2 minus y1 over x2 minus x1. And so I'm going to say x1, y1, x2, y2. So then I go 0 minus 2 over 9 minus 4. So that's -2/5. So that's my slope. So we get -2/5 x. Now I'm not done. We need the y-intercept. So how do we figure out our y-intercept? Well, we could use this equation, y equal mx plus b, or we could use y minus y1 equal m x minus x1. So those are things we can try to use. Now just looking at that, since we have a 9, 0, let's use this one, because then we can just say 0 equal -2/5 times 9 plus b. And so that would be 0 equal -18/5 plus b. And then just move it so we get 18/5 equal b, which means y equal -2/5 x plus 18/5. So plus 18/5. All right. If you didn't like that, we probably could have figured it out here, like y minus 0 equal -2/5 x minus 9. And y minus 0 is just y. And once it distributed, so you do -2/5 times x is -2/5 x. And a negative times a negative is a positive, and 2 times 9 is 18. So 18 goes on top. You don't multiply 5 by anything unless you think 5 times 1 is 5. And so those do match. So that's what we want. All right. So that's part A. Part B, that's this graph. And let's see, they look like they're counting by 1 still. And this is down 1, 2, 3 units and right 1. So if it's down 3, right 1, that's a slope of -3. And this one, we already know our y-intercept pretty easily. And it's -3. Because it's right on the y-axis. So what I wrote was m equal, and then I put down 3 over right 1, which is -3. And then I put y-int, which is b, is -3. Now what does that mean? It means y equal mx plus b, so it means y equal -3x minus 3. So that's going to be our first one. Now if we look at our graph, it's open, then it's closed. So this one is open, so it's not that. This one's open, closed. This one's closed, open, so it's not that. And this is closed, open, so it's not that. So we know it has to be the B answer. All right. So I know that's one challenge right there. Just which one is it? And then it's like you go -3x minus 3. And then that was when you're going from -1 to 0. So we stick a 0 right there. And then for the next part, we're going down 1, 2, 3, 4, 5, 6 units. That's down 6 and then right 2 because it's 2, -5. So down 6, right 2. Down 6, right 2 is -6/2, which is -3. Down 6, right 2. So -6/2 is -3. So that's my slope. And let's see, we know our y-intercept is 1 from the graph. So that'd be y equal -3x plus 1. -3x plus 1. And that one goes from 0 to 2. Like that. Okay, so that's number 13. Number 14 is our last one like that. Giving you lots of practice on this because you've got to remember how to get your y-intercepts even if it's not touching. Okay, so this one we start solid and then we go to a hole. So these all start solid and this one has a less than or equal to, so it's not A. These two are still alive. For the next half, it's open, then closed. So this is open, then closed, and this is closed for both of them. So that's wrong. And this one is open, then closed, and then over here, the 5 is open. Okay, so that's going to be C. Alright, so that's the first challenge again. Then we look at the graph and we're counting down 4 units because it's up 4. Okay, so 4, and then right 1, which is -4. That's our slope. And then our y-intercept is 0, so it's plus 0. So that's just y equal negative 4x. The next part is the constant part. Remember, the first part is decreasing, and then it jumped, and then your constant. The constant part is y equal 4, and that happens from 0 to 1. So we go 4 from 0 to 1. And by the way, I needed to put the little 0 right there also. Okay. Then the last part is we're counting down from 4 to 0, so that's again down 4. Now they're not parallel, and so we have to be going right something different. So if we just like draw our line, well, that's not perfect, but you're going from 1 basically to 5. So we go 1, 2, 3, 4 units. That means that your slope is 1. Well, negative 1. So negative 4 over 4 is negative 1. So that's a negative x. Negative Ghost Rider. Alright, and then we got to figure out our y-intercept, which is up here. And let's see, how do we figure that out again? We go with 1, 4 and 5, 0. We knew our slope already, and we go y equal mx plus b, put a 0 equal negative x, no, negative times 5 plus b. So when it's like that, that's the same thing as just saying negative 5 plus b, so 5 is b. So y equal negative x plus 5. So this changes to plus 5. And then this goes from 1 to 5. So a hint on this is if you got 1 here, then 1 should be here. If you got 0 here, 0 should be there. Okay, so that's part A. Part B, this one you go solid, solid. So this one can't be it because that's a less than. This is solid, solid. This is solid, open. So it can't be C. So again, based on that, we know it has to be B. And then this one, you're going up 1, right 2. So up 1, right 2, which means the slope is 1/2. So that means 1/2 x. And we know our y-intercept on that first part is 0, so you just leave it, because you would have 1/2 x plus 0, which is just 1/2 x. So that's good, and you go a 0 here, a 0 here, let's just go ahead, a 1 here and a 1 here from the graph. And then for the second part, we're doing a negative slope. We're going down 3, right 1. And so that's negative 3 for your slope. So y equal negative 3x. And then your y-intercept is 3, so plus 3. So negative 3x plus 3. Then your last part is just the constant. It's a horizontal line at negative 4. So it's just negative 4 with 1. Okay. So those do match all the numbers in here. Wow, that's already 30 minutes. Okay, so now on this one, what you have to pay very close attention to is, does your problem have the little, does it have the little bracket section on top or on bottom? If it's on top, then it's called greatest integer. If it's on bottom, then that's least integer. Okay, so that's half the battle right there, because we don't really even have to bother putting it on the calculator. If it's greatest integer, then your answer for when it's -8 is going to be -9, -8 bracket. In other words, it has a hole, and then it goes and it has a dot, like that. If it were the least integer, it'd be -8, comma, -7 bracket. Let me double check that. I think I did that wrong. I think I need a bracket -8 and a parentheses on this. I need to check that real quick. Okay, so I was right on how I fixed it. So if it's the least integer, then your bracket goes first, because it's like this and then like that. Other than that, it's kind of complicated to explain, and we've already gone 30 minutes. So maybe I could show you in class if I need to, because there is a way, because you could say, well, what is the value if it's like -8.5 or whatever. But I'm just going to leave that there for now, because I'm not a big fan of greatest and least integer, because I don't know how to do it on the calculator. I bet you could do it in the menu. If you just do the open book, and if I go to the G's, okay, no, can't do that. Okay, no. I don't see where to do that very easily. So I will just go ahead and make a decision. This one, even though you should be able to do this on the homework, because all you do is you take the number like that, or that number with the other one number. This one would not be on the quiz or the test. So I will promise that. But you can figure that out on the homework. Just practice with the greatest integer, which I think if we look it up, it just may be int. But we might just talk about that in class a little bit. All right, so moving on, now for number 16, this one we have -5/7x. So if it's regular, like 1/x, it'd be like that. If it's -1/x, it'd be like that. And so our answer is going to be in these two quadrants, says that graph. It says the B graph. If you don't just like using the parent function like I did, make sure you use your parentheses properly. So you'd say -5 divided by parentheses 7x. Got to emphasize that parentheses. And then you can graph it. So it looks like that. All right. So that's the B graph. What symmetries does it have? It's to the origin. So origin would be A. And then it's increasing throughout the whole thing, basically, except for where the asymptote is. So increasing everywhere except x equals 0. Now, what does that mean? That means that it'd be negative infinity, 0, union, 0, infinity. Okay, so I've got negative infinity as a 0, union 0 to infinity, because that's what it means when it's increasing everywhere except x equals 0. Because you basically got to think of that as your asymptote, right? And so if you put an asymptote here, that's your u. And so then you put 0 on this side and 0 on that side. Okay. And so it's increasing and it's never decreasing. Because even though it's going at different rates, so to speak, like this is going slow, then it's going fast, and this is going fast and then it's slow, they're both generally going up, even though it's not a continuous function. So that's A. All right. Just a few more. Number 17. On this one, graph it and talk about the symmetries. So we'll just use the calculator, but we know the parent function of y equal x cubed looks like this. And the only difference is it's a 1/11th in front, if you would, because that's the same thing as saying x cubed over 11. So that's going to be the C graph. And you can just graph that on your calculator. And it's going to be symmetric to the origin because it's an odd function. And it's increasing and it doesn't decrease at all. So the one with never decreasing, and that's B. And you put in negative infinity to infinity because it's increasing the whole way. All right, so there's that one. And then number 18, test whether it's even, odd, or neither. So if you have like y equal 3, for example, that'd be the horizontal line, so that's going to be even. So just think about if it's horizontal, it's even. Okay, and then number 19, this one, let's just graph it, and we go 1 over parentheses x squared minus 1. Okay, got that interruption. But we put in 1 over x squared minus 1 because even though this says t, it won't work on the calculator, so you have to put x. And when you look at it, it's symmetric left and right, which is across the y-axis, and that means it's even. Okay, and then this one, let's see, if we were to graph this one, we put a trig and then we go to sine and then do 17x. Now it's kind of wild right there because of my interval, but if you go to menu window and go to the trig window, which is 8, it'll show up a little bit better. Actually, I need to really zoom in even more, it looks like, because all I care about is the origin. So if I go to menu and then 4 for zoom, and I want to zoom in, put a plus there a couple of times. Okay, now I can see it. So that's odd because it's not even, because it's in diagonal quadrants. So it's odd. And then if you go by the definition, that means that sine of negative 17x is the same as negative sine 17x. So remember, if it's odd, what we say is f of negative x equal negative f of x, and if it's even, we say f of negative x, f of negative x equal f of x, which means back to how it was to begin with. Alright, that's the end of your video. I hope that helps.